finally, we arrive to the last subtopic for the EMT, which is a Poynting theorems. Right. So I hope you study yourself how to derive the average power for the EMT wave. We can refer to the page 510 to 512 in Sadiku. By definitions, the total power out of a volume is equal to the rate of decreasing electric and magnetic energy plus the ohmic power. So that's mean in a volume, okay, in a volume is consist of the electrical power, okay, we have the magnetic power, and also we have the ohmic power, which is the lossy part. Okay, well, from these equations we can use, this is what we call as a divergent theorem. I think you already see. The divergent theorem is basically we can relate the surface integration with a volume integrations. So here, basically the power leaving the volume, okay, this is a power leaving to the volume, is equal to the rate of decrease in energy stored in electric and magnetic field. This part, because we have the negative sign here, and also the ohmic power dissipated. Okay, we have another negative signs. So how to derive this? You have to refer to page 5110 to 511. Here, we began to the two Maxwell equation, which is the curl E is equal to negative mu del H over del T, and the curl H is equal to sigma E. This is a conduction current density plus epsilon del E over del T. This is the displacement current density that we see previously. Right, so beginning from here, we can derive the expression of the power. Sometimes the final exam will ask about the derivation, so you have to look more detail about this. Alright, here is the Poynting vectors. Okay, the symbol is just like a P, is equal to the E cross H, and the unit is watt per meter square. This is what we call a Poynting vectors. And the average power, P average, is equal to 1 over period T, and integration of from 0 to T, the Poynting vector with a dt. So basically why we call this as a Poynting vectors, because it point towards or the same direction with the propagation. Okay, this is why we call as a Poynting vectors. Right, so the average power, when we solve the integration of 1 over T Poynting vector dt, this is what you will obtain from the integrations. Okay, so the average power through any surface can also be solved by using the P average, and we integrate with the surface. So please look into detail about this, how to derive, and you have to know how to do the integration of the sinus or cosinus, depend on the questions. Okay, we see example 5. In non-magnetic medium, find the epsilon R, intrinsic impedance and power average, and total power causing S equal to 100 centimeter square on a plane 2x plus y equal to 5. Given the propagating wave is E equal to 4 sine 2 pi multiplied by 10 power of 70 minus 0.8 x z volt per meter. So this is the expression of E. This is the answers. So here you know this is a omega. This one is a beta, right? This is the direction of your propagation. This is uh, x, direction of propagations, and this is your oscillating the E oscillating along z. Right, for lossless non-magnetic medium, the mu is equal to mu naught. Okay, because the lossless non-magnetic medium. And this is equations. The beta can be determined using omega sub mu naught epsilons. So when you calculate, you got this one is 0.8. This is equal, from here. This is 0.8. You just take. And we know what is the omega, what is a mu naught. And you know epsilon naught. This is from the calculator. And then you can find what is the epsilon r by using these expressions. So later on you obtain the epsilon r is around 15. And the intrinsic impedance is equal to Z mu divided by epsilon. So mu equal to mu naught, epsilon equal to epsilon naught epsilon r. And we use epsilon r that we calculate here. And then you got the intrinsic impedance equal to 99. Next, the Poynting vector is equal to E cross H. So the expression of E is E naught, and then H is the magnitude is H equal to E naught divided by intrinsic impedance. So that's why we got these expressions. And this is in phase. So we got cos square omega t minus beta z. And then, okay, this is the expressions. And then for the p average is we have to integrate with 1 over t or Poynting vector dt. This is when you solve this, okay, we will got this expression because cos square is equal to cos, you have to solve lah, cos theta, something like this. This is just a trigonometry integration later on here. Okay, so if you solve this later on, you will get these answers. So please prove yourself lah, because I already checked it. So this is true. And then this is a normal vectors to the surface. We have the 2x plus y divided by Z5. And the p average to the surface, because this is the surface is a vectors. So the surface is this is S. Okay, we go back. You are given S is equal to 100 centimeters square, and this is the plane. So we have to find what is the vector normal to plane. Let's say the plane is like this. So this is the normal vectors. Okay, so here the normal vectors is this one. Okay, so this is the S. The S should be 100 centimeter square. You have to change to meter square. When this one is not showing, 81 is, this is milli. So this is milli. and this is the final answers. We got 7 to 5 microwatt. Okay, please double check the answers. And by this example, so we finish our course for EMP. So hopefully you study more about this, and I wish you all the best for the final exam. And thank you very much for your patience. Right, see you again. Bye.